Experiment number 1. Common laboratory operations. The objective for this experiment are to be familiar with the construction and manipulation of the Bunsen burner and to become acquainted with some common laboratory operations.
The materials needed for this experiment are beakers of different sizes, graduated cylinders, test tubes and test tube rack, Erlenmeyer flask, funnel, watch glass, glass rod, test tube holder, wire gauze, Bunsen burner, clay flame shield, water bath, a mixture of table salt, naphthalene, sand, and a dash of food coloring, activated carbon, and filter papers. Examine your Bunsen burner and locate its parts. These are the parts of a Bunsen burner and their functions. The barrel. This is where the fuel and air mixes. The air hole is the entrance of the air. The mouth. This is the place of ignition. The gas inlet is the entrance of the fuel gas. The gas regulator is the valve that controls the fuel gas coming into the gas pod. The gas pod regulates or controls the amount of fuel gas to be combusted. The collar is the movable part that regulates or controls the amount of air coming in and to close and open the air holes. The base serves as a support for the Bunsen burner. The rubber tubing is attached to the gas inlet and connect to the gas source. Before lighting the Bunsen burner, make sure that the gas regulator valve is fully closed by rotating it clockwise, and make sure that the air holes are open. Open the gas regulator valve and light a matchstick. And then open the gas cock. Until you achieve a flame of about 10 centimeters high. Open and close the air holes and notice the difference in the color of the flame. So this is the color when you open the air hole, and this is the color when you close the air hole. Put out the flame by turning off the gas cock and close the gas regulator valve. Remember, never blow out the gas flame. Measurement of volume of liquids. Fill a test tube and beaker with water up to the brim. Measure each volume separately using a graduated cylinder. In reading the volume, place the graduated cylinder on a flat surface and keep the eye at level with the lower meniscus of the liquid. Record the volume of the liquid in approximately 2 decimal places. Do the same with the water in the beaker. Record the volume of the liquid in approximately 2 decimal places and remember to keep your eye at level with the lower meniscus. Prepare a 250 ml beaker that is 3/4 full of water. Hold the beaker with water with one hand and a glass rod with the other. Hold the glass rod against the lip of the beaker containing the water and put the free end of the rod into an empty 250 ml beaker. Carefully pour the water and let it glide down the glass rod into the empty beaker. Why should one use glass rod or piece of glass tubing in transferring liquids from one vessel to another? Write your answer. Partially fill a test tube not more than 3/4 with water. Hold the test tube with a test tube holder and position it at a 45-degree angle. Heat the liquid by moving slowly back and forth through the flame in such a manner that the top of the flame is near the top of the liquid but does not touch the empty part of the test tube. Many substances have characteristic odors. Some have agreeable odors while others have disagreeable or irritating odors. Be cautious in investigating odors. Some vapors, when inhaled, can be lethal. When it is necessary to smell chemicals in the laboratory, cup your hand above the container and waft or fan the vapor towards your face. Try not to breathe in through your nose, but bring in just enough to detect the smell. Never take a direct sniff of the vapor at the mouth of the container where the concentration of the vapor is high. Prepare a water bath and place on top of a Bunsen burner using clay flame shield and wire gauze. Place the given mixture in a beaker and place the beaker in the water bath and cover it with a watch glass. Heat gently until white crystals are clinging at the bottom of the watch glass. Carefully remove the watch glass, making sure the crystals clinging to the watch glass are intact. Add 50 ml of water to the beaker containing the remaining mixture and let it stand for 2 minutes. After 2 minutes, slowly pour off the liquid to another beaker. Care must be taken to ensure that the solid remains in the container. Add activated carbon to the liquid. Mix using a stirring rod. Boil the mixture for 3 minutes and observe the changes in the appearance of the color of the liquid. Cool and reserve for the next procedure. This is how we are going to fold a filter paper. Expand the filter paper. Moisten it with water to make it stick to the side of the funnel. With the moistened filter paper in place, carefully pour the contents of the beaker reserved in the previous procedure into the funnel. Transfer 1/2 of the clear liquid to an evaporating dish. Place the evaporating dish with liquid on the ceramic center of the wire gauze, which is placed on top of the clay flame shield. Cover it with a watch glass. Allow the liquid to evaporate slowly until all the liquid has been evaporated and crystals are formed. After all the liquid has been evaporated, turn off the flame and remove the watch glass. Observe the solid left in the evaporating dish.